Hello, my dear students. Welcome back to another exciting lesson. I'm your teacher and friend, Pradeep. It feels so good to see you again. We have already talked about what AI or artificial intelligence is, how AI is all around us, and how AI must be fair and kind. Today, we will take a deeper look at how AI learns. Are you ready for this exciting journey? Let's begin. In chapter 2, we talked about machine learning. Do you remember? No? Don't worry, we will revise it together and dive a little deeper into this exciting idea. We will see how machine learning really works and understand more clearly how AI actually thinks and makes decisions. But before that, let us first understand the difference between artificial intelligence and machine learning. Many students get confused when we talk about what is the difference between artificial intelligence and machine learning. For that, let us look at the concept of AI again. What is AI? You already know this. I heard someone say artificial intelligence. Very good. AI means artificial intelligence. It means making machines smart so that they can think, learn, and make decisions like humans. AI is not just one thing. Think of AI as a big house. Inside this house, there are many rooms. Each room has something different happening. Machines in this house can do many smart activities. Let's open the doors and take a look inside. Room 1. Robotics. In this room, machines like robots are made. They help humans do different tasks like cleaning, cooking, or building things. Room 2. Language. Here, machines learn to understand and talk to us. For example, when you ask Google Assistant a question, it replies in your language. Room 3. Computer vision. In this room, machines learn to see and understand pictures and videos. This is how AI is able to recognize your face, or a phone camera can check crops in a field. Room 4. Expert systems. This room has machines that follow stored rules to give advice. For example, a system that helps doctors decide the best treatment. Room 5. Planning and decision making. In this room, machines learn to plan steps to solve problems. Like when maps tell you the fastest way to reach school. And in this big AI house, there is a very special room called machine learning. This is where AI learns new things just like we learn in school. Machine learning is what makes many modern AI systems powerful and smart. So remember, machine learning is just one room inside the big AI house. AI is the whole house and machine learning is only one part of it. Now, let us understand what is machine learning and how is it different from other kinds of learning. Let's hear a fun story about this. Imagine you have a smart robot friend called Buddy. Buddy can listen to you, play with you, answer your questions. It looks like Buddy has a brain. This brain is called AI. It gives machine power to think, learn and make decisions like humans. But wait, does Buddy know everything from the start? No. It needs to be taught from data, that is pictures, sounds, words. It looks at a lot of data and slowly learns. This process of learning is called machine learning. In chapter 2, we learnt about ways in which AI learns. Do you remember? Do not worry, let's revise together. First one was rule-based learning, where a machine is given a set of rules to follow. It follows them and is able to perform a task. Like when AI is able to play games by following the rules of the game. Or when our phones automatically points out when we type a wrong spelling. It follows two rules. One, if the typed word matches the dictionary, then do nothing. If the typed word does not match the dictionary, then underline it in red. The second way was machine learning, where the machine doesn't just follow rules, it actually learns by itself from the data we give it. Do you remember Raju from chapter 2? Raju didn't know how to play football. He didn't ask anyone what the rules are. But every evening he sat on the side and watched others play. Day after day he watched how they kicked the ball, how they made a pass, how they try and avoid the opponent players. And after 1 week, Raju jumped into the game and played really well. How did he learn? Just by watching. That's what machine learning is like. When machines that don't just follow fixed rules, but learn from watching patterns. Now you must be wondering, how do patterns really help AI in making decisions or solving a problem or answering a question? This brings us to our next section, algorithms. Students, do you remember what is an algorithm? Anyone? Yes, I heard someone say instructions at the back. Very good. You are quite right. An algorithm is a step-by-step set of instructions that are followed for solving a problem or completing a task. Think of it like a recipe or a set of steps. Just like when you make halwa, you follow steps. Add milk, add carrot, add sugar, cook, stir. An algorithm is also a recipe. But in machine learning, instructions are a recipe for solving problems. And like a cookbook has many recipes, there are also many different types of algorithms. Once AI gets data, it applies these different algorithms or set of instructions to solve a problem or answer a question. Some algorithms are used for finding groups, some for making predictions, and some for learning by trial and error. Now let's look at one type of algorithm that is used in machine learning. It is called k-nearest neighbors or KNN. I know this word might sound very difficult, but don't worry. Let's understand this together, slowly and step by step. To understand k-nearest neighbors algorithm or KNN, let's go to a market. Imagine your mother asked you and your robot friend Buddy to go to market and buy mangoes to make mango shake. She told you to select big, yellow, ripe mangoes and reject small, green, unripe mangoes. You and Buddy both went to the mango shop and selected big, ripe mangoes and put them in your basket, and rejected small green mangoes and leave them in shopkeeper's basket. But after some time, you find a mango that is medium sized and has greenish yellow color. Now you're not sure which basket this should go in. Now what will you do? Buddy tells you that it can apply the k-nearest neighbors algorithm and solve this problem. It quickly makes a graph in its brain. A graph is like a picture that helps us see information clearly. It has two lines, one going from left to right and one going from down to up. These lines help us compare different things. On the x-axis, the line going sideways, Buddy writes the color of mangoes from green to yellow. And on y-axis, the line going from down to up, Buddy writes the size of mangoes from small to big. Now Buddy starts putting dots in the graph for each mango. Mangoes that are big and yellow have their dots together on one side. Mangoes that are small and green have their dots together on the other side. Buddy's AI brain is watching this pattern carefully. Then Buddy takes the new mango. It's the medium-sized and greenish yellow mango. He puts its dot on the graph based on the size and color. This dot comes somewhere in the middle, between the two groups of dots. Now, as per KNN algorithm, do you remember its full name? Don't worry, I know it is a little difficult to remember. KNN algorithm stands for k-nearest neighbors algorithm. Now Buddy looks at the dots closest to the new mango's dot. These are called its neighbors. If most of the nearby dots belong to the mangoes that were selected, Buddy decides to keep this mango in the selected basket. But if most of the nearby dots belong to the mangoes that were rejected, Buddy decides to put this mango in the rejected basket. This way, you and Buddy are able to select the correct mangoes for the milkshake. And this is how machine learning applies the k-nearest neighbor algorithm for solving certain problems. And like KNN algorithm, there are many algorithms that AI uses to solve a problem. how machine learning helps AI to become smart. Just like us, a machine doesn't become smart in one day. It also has to learn step by step and practice a lot to get better. Let's take a look at these learning steps one by one. Data study. Data is the first and most important ingredient for machine learning. AI needs to study data to learn. Data can be anything: pictures, numbers, or words. For example, if we want a machine to tell the difference between mangoes and bananas, we must give it lots of fruit photos. Each photo is a piece of data. Finding patterns. The hidden rules inside data. When machine studies these photos, it looks for patterns. Mangoes are usually oval in shape, often yellow or green. Bananas are long and curved, usually yellow. The machine doesn't know this at the start, but by comparing many pictures, it discovers these patterns on its own. Training. Teaching the machine. Training means showing the machine lots of examples with labels. We give the computer 1,000 fruit photos, and under each one we write mango or banana. The machine practices again and again. At first, it may confuse some fruits, but slowly it adjusts its thinking and gets better. It's just like practicing math problems. At first, you make mistakes, but when you solve many problems, you slowly learn the right method. Testing. Checking the knowledge. After training, we need to check if the machine has really learned. So we show it a new fruit that it has never seen before. If it says banana, when the photo is truly banana, it means the machine has understood the pattern. If it makes mistakes, we have to give more data to the machine for practice. Students, let me ask you a question. Do you think testing is necessary after training the machine? Yes, you are absolutely right. Both testing and training are absolutely necessary. Training is like studying for an exam, solving many sample questions. Testing is like the real exam, that is, solving a new question. Only if the machine passes the test, we can say it has truly learned. This is exactly how your phone's face unlock works. Training. It studies your face from many angles when you set it up. Patterns. It notices how your eyes, nose, smile, and face shape are different from others. Testing. When you hold up your phone later, it checks if this new image matches the patterns it learned earlier. That's how machine learning works. It doesn't just memorize answers. Instead, it looks for smart patterns, just like we do when we practice something many times. Slowly, step by step, AI becomes smarter. Types of machine learning. Students, You already know that machines can learn. But did you know they don't all learn in the same way? Just like you. Sometimes you learn when a teacher explains the answer. Sometimes you discover things on your own. And sometimes you learn by trying, making mistakes, and improving. Machines also have these three styles of learning. They are called supervised learning, unsupervised learning, and reinforcement learning. Let's explore each one step by step with simple examples you can relate to. Supervised learning. Learning with a teacher. In supervised learning, the machine learns with the help of a teacher. Here, the teacher gives both things. The question, this is called the data, and the answer, this is called label. For example, the machine is shown a picture of a fruit. Along with the picture, it is told this is a mango or this is a banana. Slowly, it learns to connect the data, that is picture, with the label, that is name. So next time when you show the machine a new fruit, it can guess the correct answer. Let's take an example from healthcare. In hospitals, AI is able to help with detecting an illness called pneumonia. In pneumonia, a person's lungs get infected. It can make people cough, feel weak, and sometimes find it hard to breathe. You must be wondering, how does the machine know who has pneumonia? Well, it comes to know with the help of X-rays. Students, do you remember what is an X-ray image? An X-ray image is a photo with which doctors can look inside our body to see if everything is alright. In a hospital, doctors show machine thousands of X-ray pictures of chest. Some of these photos are of healthy lungs and some are of lungs with pneumonia. The doctors write labels on the photos. Normal for healthy lungs and pneumonia for sick lungs. The machine studies all the labeled pictures very carefully. It learns the difference between a normal chest and a chest with pneumonia. Later, when the machine sees a new chest X-ray, it can guess if the lungs look normal or if they look like pneumonia. This is supervised learning, where machines learn with labels and help us with different tasks. Unsupervised learning. Learning without a teacher. In unsupervised learning, there is no teacher and no answers are given. The AI only gets the data, like photos, numbers, or words. But nobody tells it what the right answer is. The machine then tries to find patterns and groups by itself. For example, if you give the machine 100 photos of fruits but don't tell which is mango or banana, it may notice some fruits are oval and yellow. These must be mangoes. Some fruits are long and curved. These must be bananas. So it groups them on its own. Let's take an example. Online shopping applications like Amazon, Flipkart watch what we have searched for and what we have bought. Nobody tells the AI who is a fan of sports or who is not. It silently watches what people search for and what they buy. It finds patterns on its own and starts to group people. People who buy a cricket bat generally also buy a ball or gloves. And people who buy milk generally also buy sugar and tea. This way, it is able to help us with what we may want to buy next. Third type of machine learning is reinforcement learning. Learning from rewards and mistakes. Do you know how a dog is trained? You say sit. If the dog sits, it gets a biscuit. That is reward. If it does not sit, it does not get a biscuit. That is penalty. Rewards and penalty give the dog feedback. Slowly, the dog learns to listen to your commands. This is reinforcement learning. Similarly, when a machine is given a task, it tries to do it. If it does well, it gets points or rewards. If it makes a mistake, it loses points or gets a penalty. This way, AI gets feedback and slowly it learns how to do the task well. Let's take an example. You know, machines can play games like chess and Ludo. At first, the computer does not play well. But every time it wins, it gets points. That is reward. If it loses, it gets negative points. That is a penalty. Slowly, it becomes super good, even better than humans. This is how reinforcement learning works. Machine learning around us. Machine learning is already around us in everyday life. Let's look at some examples. Autocorrect and spell check. Have you seen that if you type a wrong spelling by mistake, phone corrects it on its own? Phone's AI is able to know what you want to type because it has learned patterns from millions of sentences. Weather predictions. AI studies old weather records, temperature, rainfall, humidity, and is able to guess tomorrow's weather. Cricket predictions. AI system studies past records of cricket teams to guess match results of the next tournament. Online recommendations. Shopping sites and YouTube suggest products or videos by learning from your past choices and comparing with others. Self-driving cars. Cars learn from cameras and sensors to recognize signals, people, and roads, improving with every drive. In short, machine learning is not a thing of the future. It is already helping us every day. This brings us to our next section. Types of AI. Students, we learnt about types of AI in chapter 2. Do you remember? Let's revise together. The first type is narrow AI, the one job helper. Narrow AI means a machine or computer can do just one job smartly. But now, imagine something bigger. What if there was a robot who could talk to you, play music, solve maths, tell stories, and even answer your questions? That would be a very different kind of AI. Not narrow, but wide. almost like a human. Let's meet that next. General AI, the dream robot. Imagine what if there was a robot that could be just like a human. That is the dream of general AI. It doesn't exist yet, but scientists are trying to build it. A type of robot which, when you wake up and say, "Good morning," and the robot answers, "Good morning, you have school at 9 o'clock today." You say, "Play my favorite song," and it plays it. You ask, "What is 17 times 12?" and it gives you the answer, 204. Then you ask, "Why do we drink water when we are tired?" And it replies, "Because water gives energy and helps your body feel fresh." This robot doesn't just follow rules. It thinks, learns, talks, understands just like a real person. You can laugh with it, you can ask it to help with homework, you can tell it to clean the room. It's like having a friend who is also very, very smart. That's the idea of general AI. A machine that is not just smart at one thing, but smart at everything. But wait, right now, this kind of AI is not in your phone or computer. But scientists across the world are working day and night to build it, step by step, piece by piece. And one day, you might just meet this robot. Maybe in your home, maybe in your classroom, maybe it will even become your best friend. That day is not here yet, but it is coming. So in future, if you meet a robot who can answer anything, understand your jokes, help with studies, and cook food too, you will know this is not a narrow AI. This is general AI, the dream robot. We just saw how general AI could become a smart friend one day. But what if there was something even more powerful? This brings us to the next type of AI, which is called super AI. Now, imagine this. You ask a robot, "I want to grow rice on a mountain." And the super AI says, "Here is a new way to do it. Try this special seed and soil." It can think, learn, create, and plan not like a human, but beyond what humans can imagine. That is super AI. A machine so smart, so fast, it can do things even humans cannot. It can solve huge problems in seconds. It can build things faster than engineers. It can answer questions even scientists don't know yet. Let's say there is a big sickness in the village. Nobody knows how to cure it. The super AI might find a cure in one night, something that would take doctors years. But don't worry, super AI doesn't mean robots will take over the world. People are working to make sure it stays helpful, safe, and kind. They are building rules and regulations to guide it. Right now, super AI is just an idea. It's like a dream in a storybook. Nobody has built it yet, not even the smartest people in the world. But who knows? Maybe someone from your village will grow up and create it. Maybe that someone is you. Okay, students, now let's quickly recap what we learned today. In this chapter, we learned that AI is like a big house of smart machines. Inside this house, machine learning is a special room along with other rooms. We also saw what is machine learning. Machines don't just follow fixed rules. They learn by itself from data we give it. Just like you practice maths or football until you get better. Then we learnt about algorithms. An algorithm is a step-by-step set of instructions. Algorithm is like a recipe. One example of algorithm is K nearest neighbors algorithm, that is KNN, where the machine checks the nearest neighbors to make a decision. Then we saw stages of machine learning that help AI become smarter. Data study, studying pictures, numbers, words, finding patterns, the hidden rules inside data. Training, practicing with examples. Testing, checking if it has already learned. We also learnt about the types of machine learning. Supervised learning, where the machine is given data and its labels. Unsupervised learning, where machine is just given data and it finds patterns on its own. Reinforcement learning, where machine learns by trying, getting feedback and improving. Then we saw some examples of machine learning in real life. It's everywhere. In autocorrect, cricket prediction, shopping or video recommendations, weather prediction, and even self-driving cars. We revised the types of AI. Narrow AI does only one job. The AI that is around us today is narrow AI. General AI, which is still being built. One day it will do many things, just like humans. Super AI, smarter than humans, an idea for the future. It is not real yet. So students, today we learned about AI and machine learning. I am so proud of you. I hope you enjoyed today's video and I will see you in the next lesson. Goodbye.